Yes, please.
Yes, ma'am.
Okay. So in the last class, yesterday, we were discussing about Hadoop versus the traditional RDBMS system, which is used for storage, which we have been using for storing the data. And we have seen the various differences between the Hadoop and RDBMS. So you can say we are still using the RDBMS for the, depending upon the kind of applications, like all the banking applications, we are working with the RDBMS, because most of the time in many of such kind of applications we have the static schemas, right? And also we have to see what kind of application requirements are, whether it is read write many times or write once and read many times kind of application. So before making our decision on what kind of tools we should use for processing our data, we have to understand the application requirements. So what are the, whether it requires more of read operations, more of write operations, or write once and read many times. Can you tell me what type of application your Facebook, Twitter, and your Instagram are? In terms of the read-write operations? You all have accounts on the Facebook, Instagram, Twitter, and so many other social media web applications. Yes?
Yes, ma'am.
So can you tell me what kind of application? See, you have been a user of all these kind of applications, maybe most probably more than 4 years, right? So now you have to see the other perspective if you want to develop such kind of applications, because these are big data processing applications. So we have to understand the requirements. So can you tell me what kind of application is your Facebook or Twitter or Instagram in terms of read-write operations? So which, like Twitter has more of reads or writes, or Facebook has more of reads or writes, and what kind of your application is your Instagram?
On Instagram is more read.
More of read. So that means you have to understand, we have to see the tools which are like write ones and read more. So we can use Hadoop over there if required, for because we have a large database requirement, right? And the Twitter and the Facebook. Yes.
मैम वो भी मैम मोर रीड है बट राइट ओनली वंस नहीं है, राइट काफी टाइम कर सकते हो आप.
हाँ, तो जैसे अब ट्विटर है, ट्विटर में आप मतलब कर सकते हैं, लेकिन फ्रीक्वेंसी किसकी हाई है? सी आई एम टॉकिंग अबाउट द फ्रीक्वेंसी. ओके, सो इट हैज हाई फ्रीक्वेंसी ऑफ राइट ऑपरेशंस और हाई फ्रीक्वेंसी ऑफ रीड ऑपरेशंस.
हाई फ्रीक्वेंसी ऑफ रीड ऑपरेशन.
वेयर? फेसबुक?
यस मैम.
और ऑन ट्विटर?
High frequency of write operations.
Right. So in terms of read-write operations, now you can distinguish which application has more requirement of a tool which requires more of read operations and more of write operations. And accordingly, we have to choose the big data processing tools for storage as well as for the computation. Okay. So whenever we are talking about any of the applications, big data applications, so we have to understand what kind of requirements it has. So how we are going to deal with the users. They are going to perform the more of read operations or more of write operations. Which operation has high frequency over there? More of updates, right? So such kind of things we have to keep in mind while making a decision which particular tool is best suitable for our application, whether it is storage or it is the computation. So for you can say when we see that when we have such kind of requirements where we have to write once and read many times, Hadoop is considered to be the better solution as compared to the traditional tools which we have been using like RDBMS. So what is Hadoop? Basically, Hadoop consists of two components. One is HDFS and another is MapReduce. We have seen that when we are processing any kind of application, there are two main tasks that needs to be performed. One is storage and another is processing, or we can say that is a computation. So for storage, we say it is the component of Hadoop which is meant for storage, that is called as HDFS. The Hadoop distributed file system, which is its full form of HDFS, and it provides a reliable shared storage. We will understand what do we mean by the reliability. Then for the computation part, because it is providing it's not only the storage that is distributed, but along with that, even the computation is also distributed. And for distributed computation, the component of the Hadoop which is responsible, that is called as MapReduce. So we can say that Hadoop is a framework for distributed processing of large data set across clusters of commodity computers. So here you see we are talking about processing of large data sets across clusters of commodity computers. Commodity computers are the simple computers that we are talking about, and each computer over here is called a node. When all these nodes are connected together, we call it as a cluster, right? So how to define Hadoop? It's a software framework basically, which is used for distributed processing of large data sets across large clusters of computers. And it is basically, so what is Hadoop? It is basically the open source implementation of Google MapReduce. So basically from where it came, your Hadoop. So in 2003, Google was struggling to find out, to resolve its problem of indexing the complete World Wide Web. So we understand what is the size of World Wide Web. Can anybody tell me? Anyone tell me what is the size of World Wide Web?
I'm almost infinite.
Pardon?
काफी बहुत बड़ा है.
बहुत बड़ा है. So that means we cannot estimate, right? So basically the size of the World Wide Web is usually measured in terms of the amount of data that has been crawled by the Google, Yahoo and big search engines, right? So we say all together they make up the size of the World Wide Web. Otherwise nobody can estimate what is the size of the World Wide Web, right? So when Google was struggling with this particular problem of indexing the complete World Wide Web that it was crawling, so they came up with a research solution and they developed a Google file system, right? At the same time, so Google file system and their own computation processing system, which they call it as a MapReduce. So during the same era, you can say during that period only, in 2005, even one researcher or one scientist in the Yahoo, he was struggling to find a solution to the search engine. He was developing a search engine and he was trying to find out a solution to similar kind of problem, right? Because when we have to develop a search engine, we have to crawl the data so that it can be indexed. So what did he do? Like in 2013, Google developed its new file system, which they call as the Google file system, and for the storage of the data. So he developed Hadoop based on the research of the Google, and he called it as Hadoop. So it was a research. It is a kind of research that is going on at by these big companies, and they are also using the research work published by each other, right? So they are also looking at the research that is being going on, that is being done by the various scientists in the big companies. So that's why we call it as open source implementation of Google MapReduce. So why we are calling it open source? Because Hadoop is open source and it was developed by Yahoo, not by the Google. But the Hadoop is using the research, you can say research implementation or the research output of the Google only. So it is based on a simple data model that is called as any data will fill. That means you can upload any data, you can store any data, any kind of data into the Hadoop, that is here the component, that is HDFS component of the Hadoop. And it is a free software package which can be used. So this particular Hadoop, it has so many tools which can be used for various kinds of applications like data discovery, question answering systems, or performing any kind of data analytics on the large volume or the huge volume of data that we have. And all this task, as we have seen when we were trying to solve the problem, simple problem of finding out the maximum price of the stock, every stock. So the time was reduced from 3 hours to few minutes, right? 3 minutes rather than 30 minutes. So all this task can be done in fractions of the time that was required for solving the same problem by the traditional databases. So as I have already told you, where did Hadoop came from? Started with the research that originated by the Google, and based on that, your Yahoo, a developer from the Yahoo, dog cutting, he developed the Hadoop. And why this name was given, Hadoop was named after his son's toy elephant. So you can understand the philosophy behind assigning any kind of names. So the different names have their own histories, like the popular names. The why it is named as Google, it is also having its own history. So you can say it can be anything. Like this guy, he gave the name on the name of a toy of his son. So now let us understand the complete infrastructure of the Hadoop. So core Hadoop, as I said, it consists of two main components. One is the storage component, that is called as HDFS, that is Hadoop Distributed File System. And it is basically for distributing data across a cluster in ways that are scalable and fast. Then the second component, that is the processing component, and it is known as MapReduce. So it is a framework for processing data in ways that are reliable and fast. That means for storage, we are talking about scalability and the speed both. And here in the processing, we want reliability as well as the speed. And along with these two core components, it has an infrastructure that is needed to make them work. See, how the storage component will work and how the processing will work. In order to make them work, we have an infrastructure all around that. And this infrastructure, you can say it is the file system and the administration facility utilities which are available. Along with that, the job scheduling and monitoring, and we are going to discuss all these things one by one. So let's talk about the HDFS and then we will move on to other components. So we say that Hadoop is a distributed system like the, now before moving ahead, we have to understand how the infrastructure of Hadoop is different from the distributed databases. So you see nowadays we have distributed databases, they are also known as the cloud databases, right? So you can say the MongoDB, Cassandra, NuoDB, all these basically, they are the distributed databases. So once we have the distributed databases, how the Hadoop infrastructure or Hadoop distributed file system is related to that, or how it is different from that. So we have to understand the differences. So the key main differences between the two infrastructures, that means Hadoop infrastructure versus the distributed databases, is based on the data model, computing model, host model, as well as the design objectives. That means the purpose, the goal with which the Hadoop distributed file system is developed varies as compared to the design objectives or the objectives for which the distributed databases have been designed. So let us understand these differences one by one. So distributed databases. So distributed databases, basically when we are talking about, they deal with the tables and the relations. So all kind of distributed databases, they are dealing with the tables and the relations. But in the Hadoop, we are not dealing with the tables. We are not creating any kind of relations. We are dealing with the flat files in any of the formats. So any of the files that we create. So we are talking about that. Then in the distributed, in the databases, when we talk about RDBMS, or we say we are talking about databases, that means they must have a schema for the data. But in Hadoop, since we are talking about the files, the flat files, so you may have a doc file, you may have text file, you may have Excel sheet. So all these are files only. So we are not talking about any schema, that is not required over there. And when we are talking about the distribution of the data in the databases, we talk about data fragmentation that may be done horizontally as well as vertically. That means for the storage of data across the different nodes in the distributed databases, you break down the tables. The tables are broken down. It may be the horizontal fragmentation, like you are storing, let us say 100, the first 500 rows on one node, then next 500 on the another node, then next 500 on the another node. This is called as the horizontal fragmentation. Then another thing that can be there is you can break it vertically, that is called as a vertical fragmentation. Like, so you divide, say, like Cassandra, it works on the basis of the queries. So all the tuples which are all the, not the tuples, all the attributes of the tables which are accessed more frequently, they are stored in one node, and all other attributes are stored in the another node. That means we are dividing the complete data vertically rather than the horizontally. So that means, let us say if there are 10 attributes, 3 of them are stored on one node, and any of these 3 may be there because they are accessed more frequently by the users as compared to the other 7. So all the other 7 will be stored in some other node, and the 3 of them will be stored on the node from there, where they can be accessed at a faster pace, or they can be accessed very fast as compared to the others because they are required more frequently by the users. But in case of Hadoop, because there are no tables, what is being done, the files are divided into blocks. So how these files are divided, we don't know about that. So all this task is being done by the Hadoop itself. The management utilities of the Hadoop infrastructure itself is responsible for dividing the files into the blocks. So this is the difference between the distributed databases, that is data model. Now the computing model. So when we talk about the computing model here in the distributed databases, so everything is performed in the form of transactions. You perform any of the operations like insert, delete, update. All these processing is being done, so everything is considered as a transaction. And in these transactions, what kind of properties are being followed? They are the ACID properties. Can anybody tell me what is the full form of ACID? Yes, full form of ACID. It's a basic question, but you have studied about DBMS. What does this abbreviation stand for? ACID.
Ma'am, atomicity, consistency, durability, and ma'am, I याद नहीं है.
I is isolation.
Okay.
ठीक है. So what is atomicity? Anybody can tell me? What is atomicity? I think in the question paper, I will have to ask these small questions. You people are not remembering that also. This is a very basic thing that should be on your tips.
Multiple operations can be done in single.
See, if I have to take out money from the bank, then how it will be performed? So multiple operations are involved, but that is considered as one atomic transaction. Okay. So that is the smallest unit of transaction, we say atomicity, right? So once this transaction is complete, only then the other actions can be performed on that particular database, right? Consistency?
That the data is consistent all through when the transaction start and when the transaction ends.
Perfect. Isolation? Billions of users, yes, multiple users, multiple transactions
must occur independent of each other.
Yes, they should not interfere, right? So they work in isolation, right? As if only one transaction is being occurred, right? And durability?
Ma'am, changes made will be permanent.
Pardon?
Ma'am, whatever changes are made are permanent.
Okay, what the other one was saying?
Yes, ma'am, Sam, whatever changes were made successfully, they will be permanent.
Right. Perfect. So you should know these basic things when we are talking about, when we are talking about storage, we are talking about databases only, and you should know the differences, how Hadoop would, because in the Hadoop we have two components. One is storage. So when we are talking about storage, we are talking about databases, the persistent storage we are talking about. So anybody can ask any kind of questions. It may be related to the simple databases. It may be related to the distributed databases, whatever is relevant and whatever is new, all the new technologies available, right? So you should know about all these things. So if one question is asked about distributed databases and you use the word ACID properties, then you should know what are these ACID properties also, right? And then we say that the distributed transactions. And in case of Hadoop, the notion of job, that means we are talking about the computing model. Here, in the distributed databases, the computation is in the form of the transactions. But in case of Hadoop, it is in the form of task, right? And that computing model, we say it is a map reduce model. And every task that we do, every job that is being done. So here you can say all the computations which are required, they are basically the task to be performed. And every task is either a map or a reduced task. We will be discussing in detail about the map reduce model. So here we are just trying to understand how the computing model of Hadoop is different from the distributed databases. Then if we understand the data characteristics, so in Hadoop, we have already discussed it is a batch processing system rather than the interactive user access. So it can process large sets of files like from gigabytes to terabytes, and the limit of the RDBMS is up to the gigabytes. So that means for if the size of data is more than the gigabytes, we should go for the Hadoop. And here you see whatever we may not, when we are going to practice, since we are in the learning stage, we may not be processing the gigabyte size files or terabyte size files. We may be using the small size files, but because we are learning, and once we know how to process, after that we can use the big size files for the further processing. And it requires high aggregate data bandwidth that we have understood when we are performing the communication. So it can scale to hundreds of nodes in a cluster. There is no end to it, that what should be the size of the cluster, how many nodes are there, right? So tens to millions of files in a single stance, they can be processed. And as we have already discussed, it is write once and read many kind of, it is suitable for these kind of applications which require write once and read many times. So that means where the frequency of read operations is high, we should choose this kind of data storage. And map reduce application fits perfectly to this particular model. So once we have written everything, after that you can read it at a high frequency as how many times you want to do that. So why Hadoop? Basically, again, because its infrastructure is very efficient, it can process the data in parallel on the nodes where the data is located, highly scalable and cost effective, and very reliable. So let us understand how the scalability and reliability are supported in the Hadoop. So it is distributed file system, so we can compute the thousands of compute nodes we can have. So if we can have large number of nodes, that means it is highly scalable. So we can, as the size of the data increases, we can add more and more nodes to that particular cluster, or we can increase the number of clusters, and we can handle the petabytes of data. So a collection of servers, as I told you, that a collection of servers which run on Hadoop or running on Hadoop software, this is called as a cluster. And each cluster, each individual server within a cluster is called as node. And typically, your standard rack mount servers, they are running on the Linux. And each node stores both. Each node has both store and process data. So, as I discussed in the example itself, in order to reduce the data access rate, we said bring the storage close to the computation. So if we have the storage, let us say, like if we are using our laptops, our storage as well as processing is being done on the same laptop. If your data is on the another laptop and you are going to fetch the data through the network, obviously it is going to involve some delays. So that's why we say that when we have distributed the data, so store the data which is to be processed on that particular node on the same node only, right? So we say each node will have both the storage as well as the processing of the data. Add more nodes to the cluster so that we can further increase the scalability. And a cluster may contain up to several thousand nodes. Facebook and Yahoo, you just check out how many clusters, running clusters in excess of 4,000. So this is just a tentative idea. Just look at this data may be obsolete also. So you just check out, you should know, just look at the pictures. Let me see. We can look at the data centers. So just a minute. See, look at the picture. The data centers. See, this is the data center outside building. And inside that, see, this is the kind of structure they have inside the Yahoo Computing Cube. So here you can see these are the racks, right? So in the racks, they have the nodes, and this complete rack forms one complete cluster. So in the one rack, they may be having 15, 20, or 30 nodes within that. And all these nodes, you see, they are placed very close to each other. So the nodes which are closest, they have when we have to access the data from the another node, so that there is a low bandwidth requirement, right? And here you can see this is the outside view of the Yahoo data centers, right? So you can say they are complete buildings which are the data centers of the Yahoo and Google also. Let us just have the pic. See, this is how they look. So they are very neat. They are so beautiful, you know. So see how many computers. See, these are the racks in which all the nodes are being placed. See, these are the nodes which are available, and you can say these nodes are connected to each other in order to form the clusters. And we have the thousands and thousands of clusters, right? So here you can see just a glimpse. Spend $1.1 billion on new data centers. So this is a glimpse of the data centers with of all these companies that they have, right? Right. So you can see when they are using the number of nodes and multiple clusters, they are basically, because they have to deal with the billions of users that we have, and Google is already running huge number of applications. So in order to deal with all these users across multiple applications, they have used data centers. Then how they ensure the reliability? See, the reliability and the availability, they are two things. Can anybody tell me what is reliability? Yes? See, earlier, traditionally, it was very expensive because your expensive hardware, redundancy, and auxiliary resources, and lot of training was required in order to handle this. See, reliability and availability, they are very less expensive when we are working with the Hadoop. So what is reliability? So reliability is like we are running a system and will not fail. And even if it fails, what are we going to do? Right? So we have seen in these data centers, all these nodes, they are placed very close to each other. And if a node fails, just replace it, one of the options. At Google's, the servers are not bolted. So that means they have not bolted the servers permanently into the racks. They are just attached to it with the help of the Velcro in anticipation that in case one of the server fails, they can replace it quickly. See, like we are wearing the Velcro shoes. We use the Velcro shoes because they are very easy to take out and put in, right? And if we have the threads to put on the lace in order to wear the shoes, that takes time. So it is like where the Velcro, if it is attached, so we can do the things faster, we can do the replacement faster. So they are now using the Velcro instead of the bolting the servers into the racks. So that's why we say if the node fails, it can be replaced very fast. So they are reliable systems. And if the task fails, so in the Hadoop system, understand everything we perform is in the form of a task. It will automatically run somewhere else because we are talking about Hadoop distributed file system, HDFS. Since everything is distributed, so that means if one node fails, the same task can be taken over by the another node. So that means there is a rigorous communication between all the nodes, right? So they are also listening to each other. There is some responsibility whether the other node is active or not. So how they are doing it, we will be discussing that in detail. So that means if the task fails at one node, the other, it will be automatically running somewhere else. So no data will be lost. There is no loss of data. Fault tolerance. So adding nodes increases the chances of any one of them will fail. We always know, we have come across many times that our laptops are being crashed. So after that, we are not left with any choice because we have not stored the data somewhere else. If we develop a habit that whatever data is we feel very important to us, we keep a copy of that data into our drives or some pen drive or Google Drive or somewhere. In that case, we will have to bear less loss of data. But that takes time. So that is a matter of habit, right? So here what is being done? Your Hadoop system, it builds redundancy into the system and handles the failures automatically. How? So every data, every block, so since it breaks the file into the blocks and each block is replicated across at least 3 nodes. So I told you the replication factor of 3 is most commonly considered. So once the replication is being done, if one node fails, the data stored, we have seen, see, one node fails and each node is having both storage and performing the computation also. So if the complete node fails, we may lose the data, but we in Hadoop, we don't have to be worry about, because the storage, if let us say 3 blocks are stored in node 1 and it fails, the duplicate copies of these blocks are also stored in node X and node Y. So data is not lost. Then we save the computation. We have already seen that in case of computation also, if the machine fails, some other node will take over that particular task which was being done by the node 1. So since we already have the data on the other nodes, so with the help of that particular data, the user will never have to you can say feel anything that there is some failure that has happened at the data centers of, let us say, the Google or the Yahoo. So these are basically, that's why we call them as the fault tolerant systems, because they have already used the technique for handling the faults that may happen. So files loaded into HDFS are replicated, and if node fails, data is re-replicated using one of the other copies, and data processing jobs are broken into individual. So each task takes a small amount of data as input. Thousands of tasks often run in parallel in these systems. And if a node fails during the processing, each task is rescheduled elsewhere, as I have already explained to you. Now, how reliability, availability, and fault tolerance are provided? A file in, we know, I have already discussed, a file in Hadoop is already broken down into the blocks, and each, see, we have to understand what is the size of the block. So in the previous version, the first version of Hadoop, the block size was 64 MB, but in the next version, the new version 2.x that we are going to use, the size of the block is 128 MB. So whatever is the size of the your file that you have, it is broken down into block size of 128 MB that you have to understand. So it is distributed across the clusters and replicated across multiple nodes of the cluster, as the replication factor is 3. And what is the consequence? What is the resultant output of performing all these tasks which are being done by the Hadoop? If a machine fails, no data is lost. Task can run anywhere else where the data resides. If the task fails, it can be dispatched to any of the nodes which contain redundant copies of the same data block. And when a failed node comes back online, it can automatically be reintegrated into the system, so to perform its task. As it happens, like, just taking a live example, that during this pandemic period, many faculties were facing this problem. They suffered COVID, so their task was given to the other faculties. And when they came back, the task was again rescheduled, and they were given their own task, and they were performing this. So there was no loss to the students. That students were given the students were not bearing any kind of loss of the classes, because one of the faculties or few faculty members, they were suffering from the COVID. So this is, you can say, the automated system that is being there. So we call it as a fault tolerant system in the Hadoop, because of which this Hadoop has become popular, and you can say because of its efficiency, its reliability, availability, the Hadoop is being used by the industry for handling the big data process and big data storage as well as the processing. So rest of the part we will be covering in the next class. We are going to get into the details. So just see this thing when we talk about the various kinds of file systems. So go through the. Can you tell me what is the file system for Microsoft? Like here you say the files. Have you studied about the file system of Microsoft? We have been using the Windows for a long time, so you may be aware about the FAT32, NTFS. Yes. And the file system of your Apple, that is HFS, HSF, S plus, then the file system of Linux. So what do you know about these traditional file systems? Can anybody tell me? You all have studied about the operating systems course, and there in that particular course you must have studied about the file system. Yes. So I want you to read, just have a glimpse of that, because we are saying we are going to study about HDFS, that is Hadoop is based on a file system. It is not data model of Hadoop is different from the databases. And so it is relevant to the traditional file system also. So I'll say that just have a glimpse, just give a reading to the various file systems of the popular operating systems that we have, that is Microsoft, then Apple, then Linux. Okay, so go through it and we will have a brief discussion regarding this in the next class. If you have any queries, you can ask. Yes? Any queries you have?
Using it, is it differ in using with Hadoop in Windows versus Linux system?
In what way? No, only like for Java, when we use the runtime environment is different for the, but at the at the upper level there is no difference. Only thing is when you are installing it. So in that case, for the Windows you have to pick up a different file, and for the Linux you have to pick up a different file.
Yes, ma'am.
Only
But
that
while
difference.
using Hadoop, there will be difference.
No.
While
There won't be
using
any.
Hadoop.
No.
Okay.
Once we have installed that, there is no difference in the environment. I'll upload. See, we couldn't have the tutorial this time because there was some problem and I was on leave. So I'll upload one file of the tutorial sheet. So there I have given you the details for the software. One is the Cloudera framework that you can install on your machines, but the problem is your machine should have minimum of 8 GB RAM for installing the Cloudera framework. So once you have installed the Cloudera framework, it is having, Hadoop is a complete framework, no? Now, because when you have to install the Hadoop, you have to do so many configurations. So instead of doing that, two famous frameworks are available. One is Hatron and another is Cloudera. Cloudera for the personal use is free. So you can download it from there, and that is basically a zip file. So I have given in the tutorial sheet, I have given you all the instructions as well as the links in order to install the Cloudera on your own machines. Another option that I have given over here is that if you don't have the supporting hardware, like your laptop RAM is less than most of the time we have 4 GB RAM, right? So in that case, there is one course that is running online, that is Hadoop in the real world. So what they have along with their course, they are providing you an option to practice online. So through the telnet, we can access their server and do all the practice of the Hadoop commands, whatever task we want to do in the Hadoop on their server, right? So for that also, I have given you all the links. So you can register over there, and when you register, just after the registration, you will be given all the details for the host name and the IP address through which you can connect to their server and then practice all the HDFS commands. So step by step, as we move further, I'll provide you the links to practice online itself if you are not able to install Cloudera on your machines. Okay. So I'll be uploading in the classroom. You today see the tutorial 1. I'll be uploading that and go through that. If you face any kind of problem, just let me know. So by that time, I'll take your attendance. But attend your roll calls. Digala, Ruchit,
Ma'am,
Sarthak.
present. Ruchit.
Okay. Sarthak, Devesh,
Yes, ma'am.
Dhaval, Nandini, Shivani, Aman, Harsh,
Present, ma'am.
Harsh Nayar, Hemant, Vikas
Present,
Gaur,
ma'am.
Vishwajit, Akshay, Anshuman, Rishabh, Shivam, Sparsh Arora, Yash Agarwal, Kunal Pratap, Priyansh, Nikunj, Asmit,
Present, ma'am.
Siddhant Wadhwa,
Present, ma'am.
Tanishq, Pranshu,
Ma'am, Pranchu
Soumya
has
Rai.
lost connectivity. He has written in WhatsApp.
Okay. Soumya, Anshika,
Present, ma'am.
Mudit, Pratyush,
Present, ma'am.
Rajesh Kumar,
Present, ma'am.
Saransh, Siddharth Goyal,
Present, ma'am.
Sudhanshu.
Yes, ma'am.
Anyone left for attendance? Okay, Bicha, you can be.